Alright, in this video we're going to cover two CodeWars exercises, one of them going from Roman numerals to a Python integer, and the other going back to the beginning. The recent Super Bowl 58 was LVIII, which means you look up each one and add the results. L is 50, V is 5, and the I's are 1s. But that's not always how it works. For example, next year, 59 will use an IX for the 9, and you can't add those. You'd get 11. So throughout this, you'll see different ways that we might handle those combos, either treating them as combos or subtracting the first when you either look ahead and see the next guy is bigger, or you look behind and see that you should have subtracted that one. So here we've got the problem, and then I started with the list of tuples because most of my classes are studying lists and tuples just to get the data down. If we want to look one up, we can say look up, take a character, and check each one until we see it. If we give it X, it'll say first line, is that an X? No. Second one, is that an X? No. Third one, yes, so I'm going to give you 10. Then we can take each character down the line and add those. If we had XVI, we'd go 10, 5, 6 and get 16. However, we got to handle those combos, so the way I decided to show it was peeking ahead at the next symbol, and if it's worth more than the current one, we subtract. If I'm a C, normally that's plus 100, but if I'm a C before a bigger character, well, now I'm minus because CD is 400, that's 1 away from a 5, and CM is 900, that's 1 away from 1,000. There's a problem with peeking ahead, which is that you can't do it at the end, you'll be out of bounds. So we had to add a little thing here that says if we were going to look off the edge, just pretend there was an I, which will mean no combo, because there's no combo with an I in the second position. So that's great. If you turn that in, no problem. But anyone who knows Python will probably say, how about a dictionary? We can skip the lookup because a dictionary allows you to just jump to anything in that right side based on the left. So let's say I is 1, and now if we give it I, it'll tell us that's 1. Or if we give it X, it'll tell us that's 10. Otherwise, this function is the same. It just got to be bigger because there's less stuff on the screen. Another thing you might say is that let's treat the combos as units. So IV, that's 4, rather than separately -1 and +5. CM, that's 900, rather than separately -1 and +1,000. So you can do that. And this is what I remember doing back in the day when I wrote this kind of problem in Java. We treat the combos, we look for them. If I see the next two characters are a CD or XL or whatever, then I'll take it. And then I'll tell it to skip, because when I do XL, I got to make sure that I don't count that L again and add 50 more than I should have. So in this case, we have a skip Boolean, which is not something you see in Python a lot, but maybe older procedural styles would do that kind of thing all the time. However, when you're going to take off a chunk from the beginning of something and it's not the same, a loop is not super useful. My instinct is to go for recursion, to say I'm going to take a chunk and then whatever's left, it might be a lot or it might be a little bit, I'm going to send that on through the same process we just did. So certainly this results in a shorter function because we say, hey, look for a combo, look it up, plus the solution of the rest, which means you are delaying the rest, just doing one step at a time and not worrying about balancing, skipping, or peeking, or any of that stuff. You just check it. And that's nice. The only issue is a Python slice could be empty, and maybe at the end we try to give it 1:, which is nothing. So as a default, we return 0. I don't like this kind of recursion. I think it's a little hard to follow because when I do the solution of the rest, it doesn't keep track of the state. It doesn't know what the running total is. That is waiting to be added later. So if I were going to do this kind of recursion, which I'm not saying you should, but if I were, I would pass it along inside the function as another parameter, I would say, oh, well, the result, this is our running total, and you add on to it. And then at the end, we just return result rather than like 0 plus something, plus something, plus something, plus something. That's already been done. Only issue here is this is a little repetitive, so we can use the Python walrus to give this a name and use the name later. That's pretty nice. I ended up turning in something like this on CodeWars because I thought it looked cute. Now let's try the other side, which is starting with a number, an integer, and making Roman. This is a classic type of problem. Sometimes you get a number of seconds, and they want to know how many months, how many weeks, how many days, how many hours, how many minutes, and so on. Sometimes you get a quantity of money, and you want to know how many 20s, 10s, 5s, 1s, quarters, 10s, whatever. And it's all the same, which means we're going to go down the line, take each chunk. But we want the big chunks first, so we're going to flip them around. And so I'm going to look for the M's, look for the D's, just as you would look for big bills instead of giving your customer a truck full of 20s, or a truck full of pennies, or a truck full of anything when you could have done big. Now, in this case, I'm going to throw the combos in there, and we're not really looking them up the way a dictionary would. I'm not giving this a number and saying, what symbol does that equal? So I'm using lists and tuples, which, for one thing, we don't have to switch them. I don't have to put the numbers on the left, so that's less work. And it also allows us to loop, which Python didn't until pretty recently. Python dictionaries were unordered, kind of like a set, so you couldn't reliably go through a loop in the same order. Now you can, but if you look at the solutions on CodeWars, you might see other people have used an ordered dict, which was a type specifically made to get around that limitation, and that's just the way normal dicts work now anyway. So I stretched those out across the horizontal axis just to make room, but it's the same stuff. And now our solution is saying, look at each one of these. If we can take out that chunk, or multiples of that chunk, do it, and then take the remainder. This is such a common operation, like I said, with money or time or other things, that it has a name, div mod. Div is dividing, so we might say, oh, there were 3 m's worth of stuff in there. There were 5 x's worth of stuff in there. And then the mod is the modulus, the remainder, the extra, usually a % symbol in programming languages. So you might say, okay, the year is 2024. We took out 2 m's and we had 24 left. And then we look down the line until, oh, x, we can take out a couple of those. And then we've got 4 left, and then you go find the chunk that's 4. And then this puts them in a string. So that's certainly crisp enough, and it doesn't require us to edit a lot, but you could, right? There are always a lot of ways. You could make this recursive, but it wouldn't be that interesting. You'd have to pass along a lot of info about which chunk we've covered and what's our running total and how many of each have we done. You could make this do a little work to rearrange the number first, or to separate it into chunks first. And I saw a lot of that on the CodeWars solutions from other people. For example, on the decode problem where you had to start with Roman and get an integer, I saw some people who would translate the IV into 4 i's and the IX into 9 i's and just make this strange long string, which would have looked dumb to humans, but it would make it really easy for the computer to just add them up. So you can always do kind of transformations before the work to make the work easier, but that's good enough. Let's call it a day there.